All right, let's jump right in. We hear machine learning thrown around all the time, but what does it actually mean? How does a machine, learn? Well, today we're going to break down the three main ways machines get smart, and trust me, it's way more intuitive than it sounds.
But first, let's forget about computers for a second. Let's start with a really simple question. How do you learn? How did you learn everything you know right now?
If you really think about it, it kind of boils down to a few key ways, right? We learn from teachers who show us the right answers. We learn by just exploring things and finding patterns for ourselves. And of course, we learn by trial and error. You do something right, you get a good feeling. You do something wrong, you learn not to do it again. Now here's the cool part. These are the exact same models we use to teach machines. So let's kick things off with that first one, learning from a teacher. In the world of AI, we call this supervised learning. So here's the deal with supervised learning. You give the machine a massive amount of data that already has the correct answers. We call these labels. Think of that like a giant cheat sheet. But here's the catch. A human has to go through and label all that data first. The machine's job is to then study that cheat sheet and figure out the rules for itself. This analogy just makes it so clear. Imagine you're showing a computer millions of pictures. And for every single one, you tell it, yep, that's a cat, or no, not a cat. After seeing enough of these correct examples, it starts to pick up on the patterns, the pointy ears, the whiskers, the tail. It starts to learn what a cat actually looks like. And you see this in action every single day. That spam filter in your email, that was trained on millions of emails that people, actual humans, marked as spam or not spam. Or when a real estate website predicts a house price, it's because it learned from the data of tons of other houses and their actual final sale prices. It's super powerful, but its biggest weakness is just getting all of that correctly labeled data to begin with. But even with that challenge, because it's so good at these specific, predictable tasks, supervised learning is, hands down, the most common type of machine learning you'll find out there in the world today. Okay, but what if you don't have a cheat sheet? What if you just have a giant, messy pile of data with no labels at all? Well, that brings us to our second method, learning by discovery, or what we call unsupervised learning. The big difference is right there in the name, unsupervised. There's no teacher, there are no right answers. You basically just unleash the algorithm on the raw data and tell it, go find something interesting. Its whole job is to find hidden groups and patterns all by itself. Now the trick is, a human still has to look at the patterns it finds and decide if they're actually useful. This toy box analogy is perfect. A kid doesn't have categories like vehicles or action figures pre-programmed. They just start making their own little piles based on what they see. Okay, here are all the red toys. Here are the ones with wheels. And here are all the soft, cuddly ones. The machine is doing the exact same thing, just sorting data instead of toys. This is the magic behind things like recommendation engines. You know when your streaming service just knows what you want to watch next? It's because an unsupervised algorithm has secretly grouped you with millions of other people who have similar tastes. It's also a total game changer for businesses, helping them find new types of customers they never even knew existed. All right, on to our third and final style. This one isn't about looking at data labels or finding patterns. It's all about learning by doing, through action and consequence. This is learning with rewards, also known as reinforcement learning. So with this one, the machine, which we usually call an agent, is basically dropped into an environment, like it's playing a video game. It has a goal, but zero instructions on how to get there. It learns simply by experimenting. It tries something, sees what happens, and gets a little bit of feedback, a reward for a good move or a penalty for a bad one. It takes millions and millions of tries, but eventually, it can come up with strategies that are way beyond what any human could program. The dog training analogy is just spot on. The agent, just like a puppy, doesn't know what sit means at first, but through a ton of trial and error, it eventually figures out that that one specific action, putting its spot on the floor, is the thing that gets it a treat. Now, imagine doing that millions of times a second, and you've got reinforcement learning. This is the secret sauce behind some of the most mind-blowing AI breakthroughs we've seen. When an AI beats the world's best human at a super complex game like Go, that's reinforcement learning. It literally played more games against itself than a person could play in 1,000 lifetimes, slowly rewarding the strategies that led to a win. It's also absolutely essential for things like robotics and self-driving cars. Okay, so we have the teacher, the explorer, and the student who learns by doing. Let's just pull this all together and do a quick side-by-side to make sure it all clicks. Looking at the two main data-heavy approaches like this makes the difference crystal clear.
Supervised learning is all about prediction, using a past that's been neatly labeled. Unsupervised learning, that's all about exploration, finding the hidden structure in the data you already have with no labels needed. And this table really boils it all down. You've got supervised learning, that's our teacher with the answer key. Then there's unsupervised learning, our kids sorting the toy box and finding new patterns. And finally, you have reinforcement learning, training a dog with treats, learning through trial, error, and reward. 3 totally different paths to intelligence.
So there you have it. It's kind of wild, right? Machines learn in ways that are actually pretty human. They can learn from a teacher, they can discover things for themselves, and they can learn from their mistakes. And all of that leaves us with one last big question to think about. As these machines get smarter and smarter, what's the next big lesson we hope they learn?